In this lesson, we will discuss the general power formula in taking the integral of a function. But make sure to watch our first video lesson about the basic formula of integration before you watch this lesson. Okay. For the general power formula, in taking the integral of a function, we will apply the change of variable, wherein we will try to express our given equation in terms of u and the du. And for our formula, the integral of u raised to n du is equal to u raised to the exponent of n plus 1 over that n plus 1 plus c, wherein n is any integral exponent except -1, since if n is -1, this will give us a denominator of 0, which results to undefined. For our guidelines for making a change of variable, number 1, choose a proper substitution of u in the given function, and it is best to choose the inner part of a composite function such as a quantity raised to a power. Then for number 2, find the derivative of u in terms of the x and the dx, or it simply means that we will take the derivative of the equation both sides. And after that, we will try to rewrite our given function in terms of u and the du, then try to take the integral of this function. And after we take the integral of this function, make sure to apply back substitution to replace our variable u in terms of the original function. Let's try now to have an example problems for this topic. For our first problem, the integral of 1 over the square root of x plus 1 dx. Take note that the square root is the same as a fractional exponent of raised to 1/2. And having an exponent in the denominator can be rewritten as having a negative exponent, wherein this equation is simply the same with the integral of x plus 1 raised to the -1/2 dx. Again, the square root is the same as raised to 1/2, and applying law of negative exponent, that is x plus 1/2 raised to -1/2. Then since we cannot apply basic formula of integration here to solve for this problem, let's now try to apply the change of variable, wherein let's try to let the x plus 1, this is a function raised to an exponent, to a variable u. Let u to be the x plus 1. And after that, let's try to take the derivative of this equation both sides. And taking the derivative of u without any respect, this is simply as du. Then for the derivative of x plus 1, take note, for the derivative of x without any respect, this is equal to dx. And for the derivative of 1, that is a 0, since the derivative of a constant is always equal to 0. This is dx because we take the derivative of the function without any respect. And after that, let's now try to rewrite our equation in terms of the u and the du, wherein our function is the same as taking the integral of the x plus 1 is equal with u. This is now u raised to -1/2. Then for our dx, take note that this is equal to du. Then, applying the power formula, which is for the integral of u raised to n du, wherein our n is any integral exponent except -1, this is equal to u raised to n plus 1 over the n plus 1 plus c. Let's now try to take the integral of u raised to -1/2 du, and this is equal to u raised to the -1/2 plus 1 over the -1/2 plus 1, then plus c. try to simplify the equation further, this is u raised to negative 1 half plus 1 is equal to positive 1 half, then over positive 1 half plus c. Take note, as we divide a fraction with a fraction, we will just simply take the reciprocal of the denominator and proceed to multiplication. Therefore, this is now equal to u raised to 1 half multiplied by the reciprocal of 1 half, which is 2, and this is 2, u raised to 1 half plus c, or this is the same as 2, the square root of u plus c. And applying back substitution, we know that the u is equal to the x plus 1. Then, therefore, our equation now will be equal to 2. From the square root of u, this is now the square root of x plus 1 plus c. And this will be our final answer for the integral of 1 over the square root of x plus 1 dx. Okay, then let's now try to have another example problem. For our second example problem, find the integral of the product of the x squared multiplied by x cubed plus 5 raised to 4 dx. We can solve this equation if you will try to expand the x cubed plus 5 raised to 4. You can apply Pascal's triangle and multiply the x squared by distributing this x squared to all the terms and apply basic formula of integration. But that is a tedious task. And instead of doing that, I will just solve this problem applying the change of variable of u, wherein we will let u as a part of the function here that has an exponent, which is a function that is raised to an exponent, and that is your x cubed plus 5. Let's try to let u to be the x cubed plus 5 on this equation. Then, let's now try to take the derivative of this equation both sides so that we can express this dx in terms of du, and this will be the derivative of u is equal to du. And for the derivative of x cubed, this is applying a power formula in taking the derivative, and that is 3 multiplied by x squared dx. And for the derivative of 5, take note, that is just a 0. And we will notice that on the given equation here, we have a product of x squared and the dx. That means if you will now try to express this x squared dx in terms of du, you can solve this as just simply divide both sides of this equation by 3. And that is now your x squared dx is equal to the du over 3. As we see, these 3 will cancel each other. And this x squared dx is equal to du over 3. Let's now try to rewrite our original function in terms of the u and the du. Wherein from our original given, we can write this one as the integral of x cubed, or the quantity of x cubed plus 5 raised to 4 multiplied by the x squared dx, wherein the x cubed plus 5 is equal with u raised to 4. And for the x squared dx, take note that this is multiplied by x squared dx is du over 3. And this over 3, or a 1/3, we can factor it out as a 1/3 the integral of u raised to 4 du. And as we see from this given now, we can apply the general power formula, wherein this is equal now to, just copy the constant 1 over 3. And for the integral of u raised to 4 du, that is u raised to 5 over 5, since that is a u raised to 4 plus 1 over the 4 plus 1, then plus c. Then, let's try to simplify the equation further by multiplying this 1/3, and this will become u raised to 5 over 3 times 5, which is 15, plus c. Then, apply back substitution wherein our u is equal to the x cube plus 5, then raised to 5 over 15, then plus c. And this will be our final answer for this given problem. Okay, then let's try to have another example problem. For our next example problem, this is the integral of x squared over the quantity of 16 minus x raised to 3, then squared dx. To solve for this problem, first, let's try to rewrite our equation applying law of negative exponent, wherein we can rewrite this one as x squared multiplied by 16 minus x cubed raised to negative 2 dx. Then, as we notice, here we have a function raised to an exponent, wherein let's try to let the 16 minus x cubed to a variable u. This is now let u as equal to 16 minus x raised to 3. Then taking the derivative of the equation both sides, for the derivative of u, that is just simply the derivative of u or du. Then for the derivative of 16, that is a 0. And for the derivative of negative x cubed, that is negative 3x squared. And for the derivative of x, that is dx. Then, we will notice that on the problem, we have here a x squared multiplied by the dx. Then, that is why we will try now to rewrite this or solve this x squared dx in terms of the du. Wherein, solving for the x squared dx, this is equal to the du over negative 3, because we will just simply divide both sides of the equation by negative 3. And this is x squared dx is now equal to the negative of du over 3. Then, let's now rewrite our equation in terms of the u and du, wherein our given originally, this is equal to the 16 minus x cubed raised to negative 2 multiplied by x squared dx. In terms of u and the du, we can express the given in terms of the 16 minus x cubed is equal to u, and this is u raised to negative 2. And for the x squared dx, this is the negative of du over 3. We have here times the negative du. This is times the negative du over 3. Wherein, this negative 1/3 can be factored out on this equation. And we will have a negative 1/3, the integral of u raised to negative 2 du. Again, we just simply factor out the negative 1 over 3. And for the integral of u raised to negative 2 du, we can apply here the power formula wherein this is now equal to, first, just copy the constant negative 1 over 3, apply power formula, and this is u raised to negative 2 plus 1 over the negative 2 plus 1. And do not forget to write the plus c. Then let's try to simplify further. This is negative 1 over 3. And for our u, this is now negative 2 plus 1. This is negative 1 over the negative 1, then plus c. Try to simplify this equation. This is the negative of the negative 1/3, which becomes positive 1/3 multiplied by u raised to negative 1. And this is 1/3 multiplied by u raised to negative 1 plus c. Or applying law of exponent, we can write this u raised to negative 1 as 1 over u. And this will become 1 over 3 multiplied by u plus c. And take note, there is no such thing as u on our given. And now, let's try to apply back substitution wherein u is equal to the 16 minus x cubed. And this is now equal to 1 over 3 multiplied by 16 minus x cubed, that is for the u, then plus c. And this will be our final answer now. Okay, then let's now try to have another example problem. For our fourth example problem, we have a integral involving an exponential function. And you will notice that on this equation, we can rewrite this square root of 1 minus e raised to x to 1 minus e raised to x raised to 1 half, because square root is the same as having a fractional exponent of 1 half. And to solve for this problem, again, we will apply the change of variable, wherein we will let u the function that has an exponent, and that is the 1 minus e raised to x. Letting u to be 1 minus e raised to x. Taking the derivative of this function, both sides, the derivative of u is du. And for the derivative of 1, that is 0. And for the derivative of the negative of e raised to x, this is, our negative is just simply a copy. And for the derivative of e raised to a function, that is e raised to the function multiplied by the derivative of the function. And that is now the negative. Copy the original function of e raised to x multiplied by the derivative of the exponent x, which is dx. And that will be our du in terms of the x and dx. And try to observe that on our equation, we have here a e raised to x multiplied by dx. On this equation of the derivative of u, let's try to solve for the e raised to x dx, wherein just simply divide both sides of the equation by -1. And we have here now a e raised to x dx is now equal to the negative of du. For our equation of the integral of e raised to x multiplied by the square root of 1 minus e raised to x dx, this is the same with the square root of 1 minus e raised to x multiplied by the e raised to x dx, wherein this is equal to the integral of, for the square root of 1 minus e raised to x, this is the same as u raised to 1 half. Okay? Since u is equal to the 1 minus e raised to x. And for our e raised to x dx, that is equal to the negative of du. Then let's try to factor out this negative sign, or this -1. This will become -1. The integral of u raised to 1 half du. And from the u raised to 1 half du, we can apply here the general power formula. And this is now equal to, first, copy the -1 or the negative. And this will be u raised to 1 half plus 1 for our exponent, over the n plus 1, which is the 1 half plus 1, then plus c. Try to simplify further. This is now negative. And for u raised to 1 half plus 1, the 1 half plus 1 is 3 over 2. This is now u raised to 3 over 2 divided by 3 over 2, then plus c. Try to simplify further. As we divide it by 3 halves, it will become the negative of 2 over 3. We will take the reciprocal of 3 halves, then proceed to multiplication, and that is -2 over 3 multiplied by u raised to 3 halves plus c. Then, apply back substitution, wherein u is the 1 minus e raised to x. And this is now negative of 2 over 3 multiplied by 1 minus e raised to x raised to 3 over 2, then plus c. And this will be our answer for our example problem 4. Then, let's proceed with our example problem number 5. For our fifth example, this is integral involving a natural logarithm, wherein we have the integral of ln of x raised to 2 over x dx. Since we have here a function that has a power or an exponent, let's try to let this function, wherein let u to be equal to ln of x. Then, taking the derivative of this equation both sides, this will gives us the derivative of u is equal to, for the derivative of ln of a function, take note that the formula is the derivative of the function divided by the given function, wherein this is the derivative of the given function x, and that is now dx over the given function of x. Now, our dx over x is simply the same with du. Let's try now to rewrite our equation, wherein the integral of ln of x raised to 2, take note, this is the same as multiplied by the dx over x. Then, for the ln of x, take note that this is equal to u, then squared. And for the dx over x, take note that this is equal with du. And we will notice now that we can apply the power formula for the integral of u raised to 2, which is u raised to n plus 1, which is 2 plus 1, that is 3, over 3, then plus c. And apply back substitution, our u is equal to the ln of x, then raised to 3, over 3, then plus c. And this will be our final answer for the integral of the ln of x raised to 2 over x dx. For our last example problem, we have an integral involving a trigonometric functions. For the integral of cosine of to the fifth x multiplied by sine x dx, take note that this question is simply the same as for the cosine raised to the 5x. This is the same with cosine of x raised to the fifth power multiplied by the sine of x dx. And as we observe on this given, we have a function that has a power or exponent, and by that, it is a hint that we can apply the change of variable leading to a power formula. Now, let's try to let u as the cosine of x. Then, taking the derivative of this equation both sides, this is du. And take note, for the derivative of the cosine of a function, this is the negative of the sine of the function, which is the negative sine of x, then multiplied by the derivative of the function, and for the derivative of the x, that is equal with dx. Then, since on our question we have here the product of sine of x dx, let's try now to solve for the sine x dx, which is just simply divide both sides by the negative 1, and we will be having here a sine of x dx, and this is equal to the negative of du. Okay? Now, for our question, we can write this one, or we can express this one as, for the integral of the cosine of x raised to the fifth multiplied by sine x dx, this is the same as u raised to the fifth power. And for the sine of x dx, this is the same as the negative of du. Take note that we can factor out the constant, which is the negative 1, the integral of u raised to 5 du, and apply now the power formula, which is copy that negative 1 and u raised to 5 plus 1 over the 5 plus 1 plus c. Then this is now equal to the negative of u raised to 6 over 6 plus c. And take note, our u is the cosine of x, and this is now the negative of the cosine of x raised to 6 over 6 plus c. Or we can write our answer in terms of the negative cosine of x raised to the 6th power over 6 plus c. And this is our final answer for the integral of the cosine of x to the fifth raised to the sine of x dx. And that's it for our discussion for the general power formula in taking the integral of a function.